Hi there, it's Ryan. So what we have here on the bench today, quite obviously, is a 64, a very, very dirty 64. I have no idea if it's in working order or not. Didn't come with any cords, no power supply. Not going to be a problem there. I wouldn't use an old power supply with it anyway. I have another one here that I'll use when I test it out. So I think even before I do the cleaning, let's hook it up and let's just see what happens. See if it has any power, see if it works or not, and go from there. Okay, going handheld for a minute here, so we'll try to keep it not jiggling. So I've got this hooked up with an Atom power supply from Commodore forever. This is the one I normally use with my 128, but now that I've fixed up a couple of my 128 power supplies, I can use those for the 128 and the Atom for the 64. I've got the computer hooked up to a 1702 that I know is good. I know it's got good audio, good video. So let's turn this thing on and see what happens. Well, there was a sound, but you can see there's no power light. It does seem like it's pushing out some kind of signal to the monitor, though. Okay, so we know this is not in working order at the moment. You can see the difference between when it's off and when it's on. So clearly something's getting sent to the monitor. So we'll turn it off and take it apart, give it a good cleaning, see if we can find anything obvious in there that's causing the problem. Alright, let's pull the keyboard connector and the LED. Let's take this shield off and see what it looks like under there. Well, I don't see anything immediately that would be an obvious cause for the problem, so I'm going to proceed with the cleaning. We'll get this all cleaned up and then we'll start troubleshooting to see if we can figure out exactly why we're not coming on. Okay, so here's the board all cleaned up, and there are a few interesting things about this board that I want to point out. First, you'll notice there's no RF cage around the VIC-2 chip. Never was from the factory, but you can still clearly see on the board where one was intended to go. So for whatever reason in this revision, they just decided that it wasn't necessary. And this is the 65-67 revision 8 chip. And you'll notice the date here is week 1 of 1986. All the chips on the board are either very late 85 or fairly early 86. And we'll come back to that here in just a second. If we look at the CPU, this is the 8500 chip, which is a version of the 6510, and the 8500 was produced starting in 1985. This one is actually dated week 5 of 1986, and that's the most recent chip on the board, so it gives us a really good idea of when the board was actually made. Now the 8500 is interesting because it's an HMOS version of the 6510, which was the older NMOS technology. Now what does that mean? Well, simply put, HMOS is basically just an evolution of NMOS with a smaller structure, which allows it to use less voltage, generate less heat, and be a little more reliable. Now when the 64C came out, and that also came out in '86, Commodore began producing new versions of all the main chips using the HMOS technology, and those chips had model numbers beginning with 85 instead of the 65 that the older NMOS chips used. So we get, for instance, the 6510, which is an NMOS chip, and the 8500, which is HMOS. The SID is the 6581, and it's the R3 version, and it's dated week 48 of 1985. Now that's interesting because that places it at the very end of the revision 3 run, because the version 4 SIDs began production in week 49 of 1985. So this is one of the very last revision 3 SID chips. This is assembly number 250425, which was the last version that was exclusive to the bread bin design. Now this board was produced in '86. That's the same year the 64C came out. And some very late bread bins do have a later revision, number 250466, but that board was also used in some of the early 64Cs as well. So this board revision is, in some ways, the last of its generation. So I think what this shows is this is a really neat board because it gives us a snapshot of the evolution of the technology and the evolution of the 64 in progress. You've got this, you know, the last board that's dedicated to the bread bin, but you've got the very last run of the version 3 SIDs, but you've also got an early HMOS processor. So I think that's interesting. Now I am going to replace all the capacitors, and I'm going to pull the RF modulator here and replace the caps inside here too. This is actually not that hard to get off of there, but the whole unit does have to come off. You just have to turn these little metal tabs, and there's usually even on like the VIC, there's some things that have to be desoldered, but it's not a big deal. It comes off actually pretty easy. And then you'll have access to the bottom of this board, which will let me get in there to change out those caps. But I don't think that the problem that I'm having is related to the capacitors. None of them seem to be leaking. None of them seem to be bloated. So I don't think the capacitors, the electrolytics, are bad. At least not to a degree that would cause the thing to not work. So I am going to change them, but not just yet. I want to figure out what's actually wrong with the thing first before I start swapping out capacitors. So the next thing I'm going to do is just to hook this thing back up and start doing some diagnostics and see if I can figure out exactly why it's not working. Okay, something totally bizarre just happened. I just plugged it in to start testing, and it's working. So I have absolutely no idea what just happened here, but I don't know if it was just the process of cleaning it or maybe something isn't quite seated right. I'm going to double check the solder connections on the power connector and the video jack and see if maybe something was just loose. But hey, this thing seems to work. Now, we still need to do some diagnostics and check things like the SID chip. But at this point, I'm going to check those solder connections and replace the capacitors. And we seem to have a system that for the most part is working. Okay, so I'm about ready to start the recapping, but there is one thing I wanted to show you because it doesn't get shown on most videos. Even when they're doing recapping of a 64 board, they don't generally show this part. In order to change these three capacitors inside the RF module, the whole module has to be removed because you can't get to them from the underside. So, what we have to do, there are a few of these little metal tabs here that just have to be turned, and then they'll be free. But there's also a few places where we have to desolder the module. Now, I've marked those here in red. What I usually do when I'm changing caps or desoldering something is I'll go through and I'll find the capacitor leads and I'll mark them with a red Sharpie, just so that when I'm actually doing the desoldering, I don't have to sit there and hunt for them while I've got a hot soldering iron in my hand. And when you remove the solder, then the red Sharpie goes away too, so there's no permanent marks left on the board. Okay, so I'm going to go ahead and I'm going to desolder these 4 pins and turn these, and we'll see if it pops right out. Okay, so I have twisted the tabs here, desoldered the pins. Now it looks like also, it's not wanting to come out right away, but it looks like there's these 4 pins here and 4 more here. And if we flip the board over, you can see that those correspond to these 2, which seem to go all the way through. The other components don't, but these 2 apparently do. So we just need to also desolder these. Okay, so I've removed the unit. You can see once I removed these 4 pins on either side here, it came out fairly quickly and easily. Here's the unit. There's these pins here that needed to be desoldered. And it's a nice little contained unit. Now, to get to the caps, all we have to do is pop this bottom part off. You can see it just sits on there. Needs some cleaning in there. And then we'll just locate the caps here, desolder, replace. Not a problem. Alright, here we go. So the board has been completely recapped, all new electrolytic capacitors, including in the RF module. So every time I do this, I like to test it one more time before I start putting everything back together, just to make sure that I didn't screw something up. So again, we're hooked up with the Atom power supply and a working 1702. So let's see what happens. Excellent. Everything looks good. Alright, so the next step is going to be simply to put the bottom shield back on, get it back in the bottom part of the case, and start working on the keyboard. Okay, you can see now that the board is mounted back in the bottom case. One other thing I want to do before I put this away is it came with this metal shield. Now this is an RF shield, but it also acts as a heat sink as these little fingers press down on certain chips. Now if we look at which chips these press down on, they're going to press down on the SID, the processor, the PLA, the VIC chip, all of which great ideas to heat sink, but they also press down on the ROM chips. So here we have the character ROM, the kernel ROM, and the basic ROM. Now, to me that seems a little odd. I've never really noticed that the ROMs get all that hot or really need to be heat sinked. I would have thought that if they were going to touch something else, they would have touched the two CIAs, but I don't know. But what I'm going to do, instead of putting the metal shield back on, and sometimes I put the metal shield on and sometimes I don't. This time I'm not going to. Instead, I'm going to use some other aluminum heat sinks here. Now, I'm going to put one on the VIC, I'm going to put one on the PLA, one on the SID, and one on the main processor. Now, how I'm going to do that? Generally, I use a thermal glue. And basically, this is just a glue that will glue this to the chip, and it has properties that allow for better heat transfer. This time I'm going to try something different. This is thermal tape, and it's just a double-sided tape. You put it on the heatsink, stick it right on the processor. Now, I personally don't have any experience with this. From what I've been told, this stuff doesn't transfer heat quite as well as the glue does, but it has the benefit of being more easily removable if we want to do that at some point in the future. So what I'm going to do is pull off just a bit of this here. And I know I've got this huge roll here, but I don't like to waste anything. So we'll get this stuck on here. And then just trim. Pull the other side of the backing off, if I can get the other side of the backing off with my clumsy fingers. There we go. And now we'll just press this down on the chip like that. And then I'll do the other chips. I've got heat sinks that are the right size for each of them. So the PLA and the SID will both use the 28 size, and the processor and the VIC chip will both use the 40 size. So I'll go ahead and do that. Okay, here's the keyboard. Now you can see just how absolutely filthy this thing is. So we're going to disassemble it completely, give it a full clean. The good thing is the shift lock key still works. All the keys, as far as I know, still work. Now to get this apart, this is a key puller. Try to get this so you can see here, and it's just basically two pieces of wire. But what it does, and I'll just pick one out of the middle here. Let's just do this one. You just push it down over it, and then it catches under the key, and then you just pull straight up, and the key pops right off. Okay? And this is just a really easy way of disassembling the keyboard, and it's really safe for the keys and for these plungers. Now, one thing that I did notice after I had the keyboard out, you have to be careful with the shift bar, because it has this metal bar that runs all the way across, so that when you push down, it pushes down evenly and doesn't go one side or the other. And if you can see here, this side of the bar is up out of its clip. So I'm going to have to be really careful taking this out and then check and see if the little plastic clip in there is broken. I've had those broken before and I've been able to kind of rebuild it. I had that happen on a 128 keyboard. And let me just show you real quick what I used to fix that. Alright, this is what I used, and I've used this for repairing lots of things, cases and other parts. It's a Epoxy Putty. Okay, it's the Odie Fix-It stick. I got this at Lowe's. I don't remember exactly how much it was, but it wasn't much. I want to say like $6 or $7. It wasn't much. But it's just a putty. You just cut off what you need, and when you work it together, and basically what you're trying to do is mix the gray part and the white part, and when you do that, because it's epoxy, when it hardens, it's rock solid. It's very, very strong. So I've used this to replace a lot of little plastic, or not replace, but repair a lot of little plastic pieces that have gotten broken. I've used it to fix cases, and it works really, really well. So if that's broken, this is what I'll use to fix it. Hopefully it's not broken, but we won't know until we get it popped off of there. Okay, so let's see if we can get that off. And look really carefully here. Okay, so what we're going to do first, we're going to just pull this straight up to pop it off of the plunger. And then, well, it looks like it went ahead and popped off. But the little metal rod here clips under these little clips here. And it looks like these are fine, so it probably just came off somehow. So that's good. That's something we don't have to fix then. Alright, and one other thing here is the shift lock key. Now, the shift lock key is handled a bit differently on different Commodore computers. On the VIC-20, for instance, you have to desolder it from the back in order to remove it. On the 64, at least on this model, there are two wires that attach here that have to be desoldered, and I've already desoldered those, obviously. So once those are removed, the mechanism is actually just held in with clips. So once we've desoldered those, we just use our puller, get it over the key, and when I pull this up, it's actually going to pull the entire mechanism out. There you go. Now you can see here there's the clips, one on either side. And if you look carefully at the keyboard, you can see, I hope you can see this here. You can see here, I hope you can see anyway, there's little tracks in here. Maybe you can see it better from the other side, and maybe not. Anyway, there's little tracks in here where those clips fit into. So you can only put it in, well, I suppose you could put it in two ways, but you can't put it in sideways, okay? And then to get the cap off, it'll just pop right off. So we can clean that separately then. And here's your mechanism. So you just have to be really careful not to break these clips when you're removing it. And to put it back in, it's real simple. You just make sure it's lined up right and just push it right back down in. The clips will snap in place, and then you resolder the wires on the other side. So I'm going to go ahead and remove the rest of these keys and get this thing cleaned up, and on the top, and get the keys cleaned up, and on the back I'm going to remove all of these little screws. This back brown part will then just come off, the membrane will be underneath it, and I'll show you that when we get to that point. Okay, so I've removed all the little screws from the back. Now this brown piece is just going to lift right up, and I'm going to lift it up and flip it over so you can see what's on the other side. See if they'll stay on there. Yeah. Okay. So you can see the printed circuits on here, and you can see all of these little, they look like suction cups. They're just there to provide the spring for the keys without actually having a physical spring. Some of the other keyboards, like the ones on the Vic for instance, actually had springs. So these use the little suction cups. Now this actually looks pretty good. You can see here where a couple of the suction cups aren't on there at the moment. You can see here and here. Those are probably, yeah, they're just sitting on the keyboard. So let's move this out of the way. Now those suction cups would come right off of there if I wanted to pop them off. They're just sitting on there. But you can see, if we look at it a little closer, see if I can get this in the light. You can see there's that little black spot in the middle there. That's actually what makes the electrical contact with the circuit board. So when you press down on the key, the cup here, this little rubber cup, compresses down, and then that makes contact on the board, and that's what registers the key press. So we'll just sit this over here back on the board for now. Okay. Now the inside here looks pretty good. You can see all the plungers. Now let's take a look at one or two of those. Just pop these things out. You can see what it looks like here, and it's got this little cross-shaped top where the key goes on. And if you look at the bottom, you can kind of see it better from this way. You see how there's four little arms sticking out from it, and the two on the side are longer than the other two. So this is only going to go into the keyboard one way. If we look at where I popped that out from, you can see that here on the sides the cutout goes all the way through the circular part here, but on the top and bottom it doesn't. So we know that this is going to have to go in just a particular way. Okay. Now I'm going to take all these plungers out. They're all identical, so you don't have to worry about where they go. You just have to worry about not losing them. So we'll flip this over and just let them all fall out. And now I'm going to clean the top of this, and then we'll start putting it all back together again. Alright, so I have everything cleaned. I have the keyboard, I have my bin of plungers, I have my bin of clean keys. So what we're going to start doing here is putting in the plungers. Now remember, they only go in a certain way. The longer legs go sideways and stretch through the gaps in the holders here. So they'll just drop right in like this. Okay, now that all the plungers are in, the next step is to get this thing back on. Now, right now, these little suction cup thingies are actually pretty well sticking on the board. So I'm not going to take them off. Don't need to. They don't really need to be cleaned at this point. So I'm just going to leave them there. If they did come off, like the one did for the function key here, I can just put it right back upside down on top of the plunger and then put the board back on. If all of these were off, and I had to clean the board or something, I would just go through and put one in each plunger. But right now, I don't have to do that, except for a couple of them that have decided to fall off. And I just need to make sure that I get them back on the right plunger. Okay, so here we go. We just flip this back over. Place it right back down where it goes. Okay. If you hold this on there, you should see that the plungers are all pushed up and set with the on top of the little cup thingies. I'm sure there's a right name for those, but I can't think of it at the moment. Alright, so now we just have to put all of our little screws back in. Okay, so if we flip it up and over, everything should be good. And they are. So, excellent. Okay, now, when it comes to putting the caps back on, I find it's easiest if you start with the biggest keys. So on the 64, really the only one to worry about is the spacebar. It's the only one you really ought to be thinking about getting on first. With the 128, the return key and then the enter key over by the numeric keypad also have these wires on them. So I would suggest getting those on first as well when you're doing those. But if you get the big ones, the complicated ones with the wires on first, it just makes everything else easy, and it gives you a little more room to work when you're putting the big ones on. Now, if you look at the side profile here of the spacebar, you can tell that this it's not symmetrical, so there's only one right way for it to go on. And if you look here, you can see this part is longer and it's curved, and this side is shorter and it's more flat. So the flatter side goes up. It goes towards all the other keys. Alright, so what we're going to do here, we're going to hold it like we're going to put it on, and we're going to start by hooking this wire underneath these clips. Okay. Okay, and if I can get it under there. Alright, so our wire is hooked under the clips. Let's see if you can see that. There we go. And now we're just going to kind of roll the key, get it over the plunger, and push down. And there we go. Now the rest of the keys are easy. You just have to make sure that you get them on in the right spot. So here's F7, F8. You just get it on there, press it down. That's all there is to it. And then you just do that with the rest of the keys. The only exception is, of course, the shift lock. So we're going to go ahead and put that back on. And again, it goes in either this way or this way. Doesn't really matter. It's symmetrical in that respect. So we're just going to take this and snap it right down in there. Okay, so here it is with all the keys put back on in the right places. And I've also resoldered the shift lock key and taped down the wires just to keep them from getting caught on anything or getting in the way. So now we're ready to put this back in the case. Okay, moment of truth. Let's see if it works. Yes. All right. So we can see that we are in possession of a perfectly functional 64 as far as we know. I do still need to hook up the diagnostic harness to it and run a test because, for instance, I don't know if the SID chip works. So I'm going to hook that up and we'll do that. Might make a different video out of that one though, because right now everything looks good. So we'll end it here. Thanks for watching.